All right, so now I want to talk. I was going to point out that there was an ice cream truck outside, but the ice cream truck stopped the second I started recording. So now I want to talk about something called degree. Do you hear it? Do you hear it? I'm not crazy. Except if you can't hear it, then I'm crazy again. Now I want to talk about degrees of freedom, and I know it sounds hard, but it really isn't. Maybe I shouldn't say that. Maybe it doesn't even sound hard, and I'm projecting that onto you. So it's not hard. It's the easiest idea in the world. Okay, an array of one dimension that we get to pick whose size can increase or decrease. It could be any size. So this dimension can be any size. Has 1 degree of freedom. Okay, and the degree of freedom is the array length. Okay. Okay. This case is our walking through or linear search through an unordered array. Okay. So this has 1 degree of freedom. Let's say we had a picture, a black and white picture, and we wanted to, so any black and white picture, so we had any black and white picture, and we wanted to develop an algorithm to see, so develop an algorithm, not develop a picture, but develop an algorithm. No one's going to understand that joke. That's a dated joke. An algorithm to see if a single pixel is black. Okay? So if one of these pixels happens to have the shade value of 0 in processing or something like that. Okay? So in that case, what we're going to have is we're going to have a picture. Okay? And what can be changed about the picture? Well, the number of rows and the number of columns. Okay? The number of rows and the number of columns. All right? And if I say that we could have n columns, okay, or n rows, let's do n rows. If I could say we could have n rows, yeah, n rows, okay, then I can say my columns are n plus m, okay, where m is any number. Okay, what I can do now is to say the number of things. So if I have a picture that's n times n plus m, right? So the number of pixels here are n squared plus nm, and that's also the number of things I have to search through. Okay, I have to search through that many pixels. Okay, so if I have 5 pixels and 7 pixels, that'll be 35 pixels. That is terrible. 35 pixels I have to search through, right? And that's m is 2 in that case, right? If I have 3 and 2, right, then m would be -1 in that case, and I have to search through 6 pixels. Okay, to find out if the answer to my question. All right, so what you might see here is that as n increases, okay, what's gonna happen? Well, the number of pixels I have to search through is actually gonna go up, not linearly, but with the squared term. Okay. And we could do that. We could do that math real quickly. So let's assume m equals 0 just to make life easier here. And at n equals 2, we have to search through 4 of these pixels, right? And n equals 15, we have to search through 15 squared, which is 225. See, I still got it. Couldn't do 5 times 7, but got that. It's going to turn out that's wrong, I bet. If it's 3, right, it's 9. We have this squared relationship going on with n, right? So n and then the number of things we have to search through, okay? And that has to do with the degrees of freedom. We actually get to pick two things here. We pick the number of rows and the number of columns, and they interact with each other. Okay? For every row we add, we're adding one thing to each column. And for every column we add, we're adding one thing to each row. So they interact with each other. You can't add a column without doing something to the rows, right? You can't add a row without doing something to the columns. All right, to the size of each column, right? Good. Okay, so what we're gonna say in this case, so if you're looking at this, if we're actually gonna graph this, which it's probably not gonna be too mind-blowing. It's gonna look like this, okay? So it's going to go up with, as n increases, it's going to go up like this parabola, right? Because it's a square term. This is our old y equals x squared, right? Or in this case, the number of things and then the number of things we have to search through, right? Have this, the number of things we have to search through equals n squared, okay? As we go up, all right? So, a few things. What about this NM situation here? Okay, I kind of made m equal to 0, all right? So we have to talk about a few things that have to do with big O rules before we actually get there, but you're starting to get an intuition. I haven't told you what we do with this or what happens with this, okay? The short answer is we're gonna ignore it. Just like we kind of ignored the scaling factor when we said these two algorithms are linear in the previous example, okay? This, we're gonna group all the parabolic examples together too, okay? We'll get there. Let's do one more. Or maybe two more.